Hi, I am Alessandro Ribeiro and you are watching the OpenGLStarter talks. Today I'm gonna talk about the PBR implementation using this framework. Before I start, I would like to read this biblical text. I heard that this phrase is the Bible summary, so I use it in a lot of places. For this is how God loved the world. He gave His only Son so that everyone who believes in Him may not perish but may have eternal life. I started to code this framework at the university. Although the name is OpenGLStarter, it has a lot of other functionalities like math, scene management, timer, threads, etc. The link to the framework is in the video description below. I'm gonna talk briefly about the PBR implementation. PBR comes from physically based rendering. We need to understand how it interacts with the graphics hardware to do our implementation. In summary, the PBR is an illumination model or a lighting model that uses real-world illumination features. It was proposed by Cook-Torrance and it uses real object properties and light properties to feed the lighting model. A detailed description could be found at the learnopengl.com. The link is in the video description below. We can start by defining some light properties and material properties. For this implementation, I use the ambient light and the sunlight. The sunlight might have an intensity, color, and a direction. The object material might have an albedo, roughness amount, and metallic amount. If you want to understand more deeply these parameters, I suggest you to watch the Naty Hoffman presentation about PBR. The link is in the video description below. Roughness is the micro irregular amount of a surface. A smooth surface will tend to have lower roughness. Metallic is a parameter that tells the amount of electric conductivity a surface has. Yes! The electric property of a material changes its visual appearance. If you want to use several lights in a 3D scene, we can use a technique called forward lighting. We can compute the ambient light, and for each other light, we sum the result with the frame buffer value. To use the Fung illumination model, this works perfectly. But we are using PBR. The main problem related to it is that it uses equations considering a linear space. But the image and monitors uses nonlinear space mapping, also called gamma or gamma space. To do the correct implementation, we need to consider the gamma value in the equations. Now, the sum is powered by gamma, as you can see in the equation. We cannot do multipass with this gamma power. To do that, we need a hardware implementation of this kind of sum. In OpenGL, we can use the frame buffer sRGB extension. If the hardware does not have this feature, we need to implement this sum in our shaders. The first implementation was using the multipass on an NVIDIA desktop card I have. But when I tried to implement it in a Raspberry Pi Model 3B+, I discovered that the graphics chip does not support this kind of sum. So we go back to the planning table. The sum of several gamma corrected values is not the same of some linear values powered by gamma. To deal with this restriction, I come up with the FrankenShader. This shader is created and compiled dynamically according to the current material and light setup of the scene. Instead of have multipass forward lighting sum, we can do a single pass to render all light information at once. If you want to see the FrankenShader class, the implementation is in the video description below. Let's go to the results. This implementation has the ambient light and the sunlight. The ambient light could use a single color or a Skybox texture access computed color. This application could run in Windows, Linux, Mac OS, or Raspbian. The source code is in the video description below. I chose this 3D model because we are in the Marys month. All the 3D model reference and Skybox reference are in the video description below. For the first site, the render shows us interesting features from the PBR. The 3D model colors blend better with the background. The original 3D model has millions of vertex. I generated the low poly version and the normal map using Blender. The link to Blender is in the video description below. I will turn on and off the normal map, so you can see the normal map magic happening here. Let's start from beginning. This is the 3D model with just the ambient light using color as input. If we turn on and off the normal map, it does not do any modification on the surface. If we turn on the Skybox based ambient light, we can see more detail in the rendering. Now the normal map makes a difference in the final image. If we turn on the sunlight, it is possible to see the illumination area. We can see the sunlight without the ambient light component result. We can make the light direction to be modified, pointing around the 3D model. And getting back all the configuration, I will show another model with this PBR shader. I hope you like the video.